Hi guys, and welcome back. Today we will solve questions on class and binary tree. So MayJune 2024 question we've solved question one in the previous video. Um, Now we solve this question two, so which is on binary tree and object-oriented programming. So I expect everyone to understand what binary tree is. Binary tree is an hierarchical data structure where each node have at most two children. So one children is the left and one children is the right. So if you take a look at this node, this is a node 15. So this node has two children which are 8 and 19. You can see the branches. So that is the reason why it's called a tree. It is called binary because one node have at most two children. Okay, it can have one child. It can also be a node with no child. Okay, so look at this node as well, two children. So for each child, this child is the left child, 8, and this child, 19, is the right child. So when we have the first number, so this is usually used for sorting, for efficient sorting, just like we have the bubble sorts or other sorts. We can also use binary tree for sorting, but in this form, we don't have to sort all the numbers, unlike other, like when we have a list, then you have to write an algorithm to sort your list. Then you can now use binary search to search. You can use bubble sort or insertion sort to sort. When you are done, then you use binary search or linear search to search. But in this case, you just enter the data. This algorithm itself sorts the data when you are entering the data. So let's take, for example, we want to enter this set of data like 15, 19, 18 in any order. When 15 is entered, the lesser number is always inserted to the left, while the bigger number is inserted to the right. Okay, so this is how it works. So let's take, for example, we need to sort these numbers 15, 9, 2, let's say 10, 5. Okay, we want to sort these numbers. So the first number will go in. Unlike other algorithm, you have to sort then before you do anything. But in this algorithm, you don't have to do that. So the first number that goes in is 15. Okay, so this is the first node, which is the parent node or the root node. Now 15 is gone. Then you need to bring in 9. To bring in 9, you have to check if 9 is less than 15. So is 9 less than 15? The answer is yes. So 9 goes to the left. So this is 9 because 9 is less than 15. So the lower values go to the left, the higher values goes to the right. Then 2. Then you check, is 2 less than 15? The answer is yes, it goes to the left. When it gets to left, there is a value 9. So we check, is 2 less than 9? The answer is yes, so this goes to the left, which is now 2. Okay, now the next value is what? Is 10. Okay, let me make this one 25. So the next value is 10. So this 10 comes and it checks 10 if it is less than 15. So 10 is less than 15, so it goes here. So 9, the next node is 9. So it checks 9. So 9 now, 10 is now greater than 9, so it goes to the right. So 10. Can you see? So the left value always goes to the left, while the lesser value goes to the left, while the bigger value goes to the right. So 10 is in. Now 25 comes. So it checks 25 with 15 and realize 25 is more than 15. So that goes to the right. Okay, so if I want to add another number, let's say 22. Okay, 22. We want to add 22. It checks 22 to 15. 22 is more than 15, so it goes to the right. There is a number at the right, which is what? Which is 25. So it checks 22 with 25 and sees that 22 is less than 25. So this actually goes to the left. Okay, so if I want to add another number, which is now, let's take for example 24. Okay, so 24 is compared to 15. It says that 24 is more than 15, it goes to the right. Now 24 is now less than 25, so it goes to the left. Now 24 is more than 22, so that goes to the right. Okay, so this is how it goes. So if I have another number, let's say 18. 18 is compared to 15, it goes to the right. Compared to 25, goes to the left. Compared to 22, goes to the left. So this is 18. Okay, so this is the binary tree. So with this, it is easy to sort data so that when you want to find any data, it's much more easy to find and much more easy to sort with this tree algorithm. I hope this is understood. So let's take, for example, you want to find a number in this binary tree. So let's take, for example, you want to find a number 22. Okay, you want to find a number 22 in this tree. So first and foremost, it checks 22 to 15. It compares the value. When it compares, it realizes that 22 is more than 15. That means it will find it towards the right. It will never find it towards the left. Can you see? Loss of time has been saved because 22 is now more than 15. So that means 22 cannot tend towards the left. It should tend towards the right. When it goes to the right, it now will compare 22 with what? With 25. When you compare 22 with 25, it knows that 22 cannot go to the right. It must be towards the left, and it is found there. Okay? If we want to find 3, then it checks. Okay? It compares 3 with 15. Then it knows that 3 cannot go to the right. 3 will go to the left because 3 is less than 15. When it goes to the left, then this is 9. It also compares 3 with 9. So comparison, the algorithm will now check to the left, not to the right, because 3 is less than 9. So when it goes to the left, it saws 2. So it's going to compare 3 with 2. Okay, when 3 is compared to 2, it realizes that 3 is more than 2. So that means it's going to check it to the right. So there's no node at the right. That means 3 does not exist. So this saves a lot of time and is more efficient because while searching for 3, it has ignored all this value at the right. Even this value even went through this node. So which makes sorting easier. Okay. Also, when you want to insert any value, values are easily inserted to its position without any stress. So let's take, for example, I want to insert 1. Okay, if I want to insert 1, 1 is compared to 15. So because 1 is less, it tends towards the left. So 1 is compared to 9. Less, it goes to the left. 1 is also compared to 2. Less, it goes to the left. Can you see? It is easier to insert. It is easier to search. Okay, now if you want to output all this value in a sorted manner, maybe ascending or descending, it's just a matter of going from 1, okay, 2, 9, 10, 15, then 22, 18, 24, 25. It will be easier to do that. So there are lots of codes that you can use your objects and class programming to achieve this. But if you look at the structure and the explanation, you see that this is much more efficient than using your bubble sort or insertion method, insertion sort or linear search or binary search. It's much more easier. So this is the concept of binary search, which is the same thing you see in this question. Okay, so this is 15. The bigger number goes to the left. The bigger number goes to the right. 8 to the left. Bigger number to the right. Then 3, which is the smaller number, to the left. So that is binary tree. Okay, but in the Cambridge exam, you will be asked to implement the binary tree in an array. So, a follow-up from the previous explanation on what binary tree is. So let's take a look at implementing binary tree in an array. Okay, in an array. So how can binary tree be implemented in an array? So let's take a look at this. let's say we have an array or a list of numbers from 15, 9, minus 3, 20, 18, 0, okay, maybe 16. We have these numbers in an array. These numbers are not sorted, but like I said, we can implement binary tree in this array. How? Let's go back to what we understood earlier, according to what I explained earlier. If I draw the binary, if you look at this, the index of the array is 0, 1, 2, 3, 4, 5, 6. So these are the index of the array. So let's put this in a binary tree. The first item or the first node will be 15, right? Now 9 is less, that means it should tend towards the left, which is 9. Minus 3 is less, minus 3 will be compared to 15, right? Then compared to 9, we tend towards the left, minus 3. Then the next number is 20, which tends towards the right, according to what I illustrated in the previous example. Then 18 tends towards the right and left of 20. Then this is 18. And what is the next? 0. 0 tends towards its left and right of minus 3. 0. And the last number is 16, which tends to the left of 18. Okay, so let me make it 19. Let me make it 19. So I have this as 19. Okay, now these are the numbers in the array and they have been placed as node in the binary tree. So let's write the index in each of the node, the index of the next element. So what do I mean by that? This is the parent node, right? Which is index 0. It is the parent. To the left of 15 is 9, and 9 belongs to index what? 1. Okay. To the right of 15 is 20, and 20 is what? Index 3. Now, if you take 9, to the left of 9 is minus 3, which is index 2. To the right of 9, there is no node. Okay. So what will be the index? So we can make it null. Okay, null, or we call it none. That is, there is nothing. Okay. So in this illustration, let null, okay, or none represents minus 1. See, this represents minus 1. That means the index to the right of 9 is minus 1. I hope this is understood. Okay, for minus 3, does it have any node to the left? No, so that will be null. To the right is 0. And what is the index of 0? 5. Okay, so let's take a look at this 20. To the right of 20, the index is what? Null. But the left of 20 is 18, which has index 4. To the right, to the right of 18 is 19, which is index 6. Okay, to the left of 18 is null, nothing. To the left of 19 is index minus 1. To the right of 19 is index what? Also minus 1. Okay, to the left of 0 is index minus 1. To the right of 0 is index minus 1. I hope this is understood. So if you take a look at this, I have drawn a different, another form of tree, binary tree, different from the previous one, but this implementing it as an array. So if I should write this, do you know that all these index that I've written now, so they are all the pointers, okay? So anything to the left is the left pointer, while the index to the right is the right pointer. Okay, can you see that the index of this array can be the left pointer, right pointer, and also the parent node? Okay, so if I would withdraw this array or this illustration, okay, if I want to withdraw this illustration, I can withdraw it this way: left pointer, okay, and data, then right pointer. Okay, now the data in the array is 15, 9, minus 3, 20, 18, 0, 19. So this is the data in the array. So to the left of 15, the index is 1. To the right, the index is 3. To the left of 9, the index is 2. To the right, the index is minus 1. Okay. To the left of minus 3, the index is minus 1. To the right of minus 3, the index is 5. To the left of 20, the index is 4. To the right of 20, the index is minus 1. Okay. To the left of 18, the index is minus 1. To the right of 18, the index is 6. To the left of 0, the index is minus 1. To the right of 0, the index is minus 1. To the left of 19, the index is minus 1. To the right of 19, the index is minus 1. So can you see that this array, the data in the array, is now a representation of the binary tree. So if we cannot, because in our console, while solving Cambridge question, we will be asked to print this binary tree in this format, okay, in this format on the console or on the terminal. Okay, this will be printed in this format on the terminal. So we will not be asked to print in this format. Okay, so since we are representing as a 1D array, it is easier to represent the binary tree in this format. So if you take a look at this information and this information is the same. But when I did the previous example, I did not mention left or right pointer. But here I have mentioned left and right pointer. So the left pointer of the first parent node is what? Is 1. The right pointer is 3. Okay. Now the second one, the left pointer is 2. The right pointer is minus 1. So this is an illustration of this binary tree. So this is the graphical representation. This is the representation as an array with implemented in an array. So this is what we are likely going to see in our Cambridge exam, since we are solving Cambridge exams. Okay, so if this is understood, so this exam we're solving in this year is illustrating this principle. I hope this is understood. So while solving the question, we will use this principle or this understanding to solve the question. That is, when the data is inserted to the array in order as it is given to the question. It is not changed, it is not sorted. But what sort this data in the array is the left and right pointer. So if anybody is looking at this structure, they may think it doesn't make a sense. But to us, we know it makes sense because it is a representation of this graphical illustration. So we know that this data is sorted in this array, right? It is sorted in this diagram, in this graphical diagram. We know it is sorted. We also know that since it is sorted in this diagram, that means it is also sorted in this array with the left and right pointer. So this is just an array. This is a binary tree, okay? So this is just an array, which is a list of what? The list of numbers. Why this is a what? This is a binary tree. So I hope this is understood. So since this is understood, so let's use this information and this idea or this knowledge and understanding to solve this question. Now that we understand the structure of a binary tree, so let's solve this question. So a computer program stores integer in a binary tree in ascending order. The program uses object-oriented programming. The binary tree the binary tree is stored as a 1D array of nodes. So we are implementing nodes. We are implementing array to represent this binary tree. Each node contains a left pointer, data value, and a right pointer. The class node stores the data about a node. Now, this is the class node. These are the attributes: left pointer, this stores the index of the node to the left, stores the index of the node to the left in the binary tree. So this, don't forget that we are trying to use a 1D array to represent the binary tree. Okay, so the left pointer stores the index of the node to the left in the binary tree. Data stores the node's data. Right pointer stores the index of the node to the right in the binary tree. Okay, so this left pointer and right pointer are storing the index of the node to the left and right respectively, while data is storing the node data. Now constructor initializes data to its parameter value, also initializes left and right pointer to -1. So get left returns, don't start, like I told you in the previous videos, you don't start typing at this point. You need to understand. You only type when you are asked to write. Okay, if you're not asked to write, you don't type. Just understand the instruction that is being passed. Okay, good. So instruction does this. Get left returns left pointer, get right returns right, get data returns this, set left, set right, and set data. Now the question states, question 2a, write program code to declare the class node and its constructor. So we are asked to declare the class node and its constructor. Okay, so these are the two things we are asked to do. Now, do not declare other methods. So we are asked not to care about other methods. We are asked not to care about other methods. Use appropriate constructor for your programming language. If you are writing in Python, include attribute declaration using comments. So we are writing code for the class node and the constructor. Okay, so let's do that now. So to write the class, we need the keyword class. Okay, the name of the class is what? Is node. Okay, so for the constructor, it is the init constructor, then self. Okay, so what does the constructor does? Initialize data to its parameter value. Initialize left and right to -1. So that means data will be passed as a what? Is the only attribute that is passed as a parameter. So I have data. Okay, so we have this as self dot data is equal to data. Okay, self dot left pointer is equal to -1. Then self dot right pointer is equal to -1. So the question asks us to use to declare attributes using comments. Okay, so the attributes are integer for left, integer for data, and integer for right. So at this point, for the left, write this as integer. For the right, integer, and for left, integer. So we can also declare this parameter as private. Okay, so we need to make these attributes as private so that it is hidden and not accessed from outside of the class. Okay, so putting this underscore before the variables, so makes it private. Okay, so now that question has been answered, we've been able to declare the class node and the constructor according to the requirement of this question. Okay, so now let's go to the next question, question II. So for question II, it states the get methods, get left, get right, and get data each return the relevant attributes. So these three methods will only return their relevant attributes. Write program code for the three get methods. So we need to go back to the table to understand to know the attributes this function will return. Okay, so this the attributes the function will return. So for get left, it returns left pointer. Get right returns right pointer. And get data returns what? The data value. So this, since we understand the relevant attribute they will return, then we can easily write their code. Okay. So we write the code for get left. Okay. Get left. Then self. Okay. So that means get left returns the left pointer. So this should return self dot left pointer. Okay. So the next function is get right. That is the next function, get right. So def get right. So self does this return self dot right pointer. Right pointer. Okay. Then the next one is get data. So def get data, then self. So this return self dot data. So we've been able to answer this question. Get left returns left pointer, get left returns left pointer, get right returns right pointer, and get data returns the data value. So which has been answered according to the requirement of this question. So which is just 3 marks. The first one was 4 marks. So this is now 3 marks. Okay. Good. Now the next question, set methods. The set methods, set left, set right, set data, takes each take a parameter. That is, each of these methods take a parameter and then store this in the relevant attributes. So before you answer this question, we are asked to write the code for the 3 set methods. So before you write the code, you must go back to the table to understand the description of what the set methods does. Okay. For the set left, assigns the parameter to the left pointer. That is, assigns the parameter it takes in to the left pointer. Okay. Set right, assigns the parameter it takes in to the right pointer, and set data assigns the parameter to the data. Okay. So to do this, so we need to write the method for the set. So the first one is set left. So df set left. Okay, then left, then the parameter. Okay, so left as the parameter. So this is now the parameter. So the description says assigns the parameter to the left pointer. This parameter that it takes in is assigned to the left pointer because this question says that this 3 method takes a parameter and then store this in the relevant attribute. So it will store the parameter it takes in into the attribute of left pointer. Okay. So that means that I have to write it as, so what is the attribute? It is self dot left pointer is equal to the parameter left. I hope this is understood. It assigns the parameter it takes into the attribute, okay? And the attribute is what? Is the left pointer. So the next method is what? Is set right. So df set right, okay? Then self, then another parameter, let me call it right. So the name of the parameter was not given, so you can use any name. So you set this to the right pointer, right? So self dot right pointer is equal to right. And the next df set data, set data, then self, um, let me call it value, or let me say data, yeah, data value. Okay, then this is self dot what dot data is equal to data value. So these questions have been answered for set left, set right, and self set data. Okay, set left, set right, set data. So we've been able to complete the question for set. The set left, set right, set. So each takes a parameter according to what you've seen here. Each takes a parameter, left, right, data value, and then store this in the relevant attributes. So each of them, the set left will store the left parameter into left pointer, the set right will set the right parameter into right pointer, and the set data sets the data value into the parameter value into the self dot data. So these three questions have been answered, and that is just 3 marks. Okay, so let's move to the next one, question 2b. The class tree data. So this is another class different from this class. So we're done with this class, node class. We're done. Okay. Now the next class, which is now the tree class. The tree class stores the data about the binary tree. So this is just a node class. This is now the tree class, which the instruction states it stores data about the binary tree. Now, tree class, which is the name of the class, it has 3 attributes. Okay, it has 3 attributes. Tree, which is the 1D array, the lower boundary of 0, 19, that means it's an array of 20 elements of type node. So the type is not integer, it is not string, the type is node. And node is the type that has been created, the object that has been created up here, which is the node. So this array must be of type node. Okay, so this is an array of 20 elements of type node. Then we have another attribute, first node, which is an integer. So this stores the index of the first node in the tree. Stores the index of the first node in the tree. Number nodes, integer, stores the quantity of nodes. That is, how many nodes do we have? Okay, so these are the 3 parameters. So the constructor initialize first node to -1. Initialize first node to -1, number nodes to 0. It also initializes each element in the tree to a node object. That is, each element in this array. Tree is an array. Okay, so it now initializes each of the elements in this array to what? To a node object with the value -1. So node objects, don't forget that this is a node class. So when you call the class with a bracket, it becomes an object. Okay, don't forget that this class requires a parameter. The class node requires a parameter, which is data. So that means the class node is called as an object with a parameter of -1 according to what this is saying. Okay, so initialize each element in the tree to a node object with data value -1. Now, we haven't been asked to write anything. That's why I'm not typing. So just read, understand what you've read before you now start typing. Insert node takes a node object as a parameter. Insert it in the array and update the pointer for its parent node. Then output tree outputs the left pointer data and the right pointer of each node in the tree. Now next, nodes cannot be deleted from the tree. So we can't delete nodes from the tree. So the question now states, write program code to declare tree class and its constructor. Just the tree class and its constructor. Do not declare other methods. So We are only concerned about this, and constructor only. Okay, the tree class and the tree class and constructor. In the constructor, these attributes will be written in the constructor. Use appropriate constructor for your programming language, which is the init constructor for Python. If you are writing in Python, include attribute declaration as what? As comment, using comment. So let's write the program code for what? For tree class and its constructor. So we'll go back to Visual Studio Code. Then we type class. The name of the class is tree class. Okay, so okay. Oh, sorry, class, tree class. Sorry about that. No self. Okay. Now, after declaring the class, the next is what? The class has been declared. The next is the constructor. Okay. For the constructor, initialize first node to -1 and number nodes to 0. So in this case, we come back here and write the constructor. So def init self. This is what I was supposed to write this self the other time. Now we initialize first node to -1. So that will be self dot underscore underscore first node is equal to -1. Okay. So first node has been initialized as what? As -1. Also number nodes to 0. So self dot underscore underscore a number nodes is equal to 0. According to the question, according to the description of constructor, first node is now -1, number node is now 0. Okay. Now the next thing, initializes each element in the tree. So before you initialize an element in the tree, the first thing is to declare the tree variable, that array. Okay, that is the first thing. So to do that, then we'll type self dot tree is equal to. So you declare that tree as an array. That is the first thing. Okay. So since we have been asked to initialize each element in the tree to a node object of -1, that means each space in the tree should have 20 values of -1, 20 values of -1 as node objects. So what does that mean? So that means we have to loop it 20 times for the 20 space in the array. So we have for x in range of 20. So this goes from 0 to 19, isn't it? Then we have self dot underscore underscore tree. I made a mistake. I was supposed to make tree to be private. I made it public. Okay, tree. Then dot what? Dot append. Remember how to initialize an array. Then what are you initializing the array to? You are initializing the array to node objects with the parameter -1. So that means you need to call the object node. Okay, you need to call node as an object. You know, node is a class. So node is a class, so you need to call it as an object. Okay. So calling it an object is writing node. So this is not an object. Okay. So you must pass the parameter of what? Of -1. So this is -1. So this means that the -1 as a node object is initialized in all the spaces or all the values of what? Of this array. So don't forget to include your declaration as a comment. So first node is an integer, first node, that is integer. Number node is also integer. Okay. So tree is an array of 20 elements of type node, an array of 20 elements of type node. Okay, so that means that all the 20 elements of what? Of this array tree now has a node value of -1 in all its elements. Okay, so this will be done how many times? 20 times. So that question has been answered. Question 2bi has been answered, which is the 4 marks. So I hope this is well understood. If you have any question, you can ask in the comment section. So let's move to 2bii. Now 2bii, still in the tree class. The method insert node takes a node object, new node, as a parameter. So this method takes this object as a parameter and inserts it into the array tree. So new node is inserted into array tree. Insert node first check if the tree is empty. To check if the tree is empty, we have to go back to the table to see this. Number node stores the quantity of nodes in the tree. So we use this variable to check the quantity of nodes. So with this, we can know if the tree is empty. And don't forget, it was initialized to 0. Okay, so to check if the tree is empty, that means we need to check the status of number node, if it is 0 or not 0. So I hope this is understood. So if the tree is empty, insert node stores new node in the array tree at index number node. So let's write that. So first and foremost, let's declare the function df insert node. Okay, so does it take any parameter? Yes, it does. It takes new node as a parameter. Okay, so I have this as self new node. Okay, now it first check if the tree is empty. So that means if self dot number nodes is equal to 0, isn't it? So this is, it checks if the tree is empty. If it is empty, it stores the new node in array tree at index number node. Okay, stores new node in the array tree at index number node. So that means self dot tree. This is the array at index what? Number node. Self dot number node is equal to new node. So this new node has been saved at the index of number nodes in the array tree. Okay, increment number nodes. So that means self dot number nodes plus equals to 1. It has been incremented by 1. Store 0 in first node. So that means self dot first node is equal to 0. So this illustrates, or this indicates that an item has been saved in first node. So let us illustrate this code and see how it works. Now, so let's take a look at these numbers. If this is the numbers we want to add into the tree, and according to this code, it says that if self dot number nodes is equal to 0, number node was 0, isn't it? Because at the beginning of the code, number node is set to 0. If you remember in this class, number node is set to 0. So since number node is 0, then the array 0 should be equal to new node. That is, the number passed as parameter, or the object passed as parameter, or the item passed as parameter should be saved in index 0, because number node is 0. So we want to save this value. So this value is saved in index 0. Okay, so this is index 0. It's saved at index 0. So I hope this is understood. Now, after that, number node is now equal to number node plus 1 is incremented by 1. So number nodes is equal to 1. Okay. First node is equal to 0. It was initially minus 1. Now it is 0. So that means that first node is 0. So first node is 0. Don't forget that since we are using the object node, that means we can access, this class can access everything in this class since we are using in first node. So we are using the object node here in this table. And if you remember, left pointer and right pointer were initially set to be what? To my minus 1. So this is what you have there. Okay. So after the first node has been added, how does the tree looks like? So for the tree, the first node has been added, which is 15, isn't it? So that implies that for that first node, the left pointer is minus 1, the right pointer is minus 1. Okay, because the left pointer and the right pointer are both minus 1. Number node is 1, meaning that we now have one node in this what? In this tree. Okay, now let's go back to the question. So the question states, if the tree is not empty, so that means we need an else statement. So don't forget that number node is now 1, which indicates that the tree is not empty. So which satisfy this else? That is, if number node is 0, it is empty, else it is not empty. So which is, it is now 1, which means it is not empty. So if the tree is not empty, insert node, that is this function insert node, stores new node in the array tree at index number nodes. Stores new node in the array tree at index number node. That means that that value new node is stored in array tree at index 1, right? So that means I have this as self.string, then self.number nodes is equal to new node. Okay, so that means that this 15 has been added initially. Okay, so 9 is just added to the array. So that is what that statement means. So 9 is now added to the array. Okay, so now that 9 has been added, access the data in the array tree at index first node. Don't forget that first node is 0. That means you access the value at the first node, which is 0, and compares it to the data in new node. What we need to do now is let us access the data at this first node. So this is the index we are currently working on. Okay, so the current node we want to work on is self.first node. That is the first node. So let me call it current is equal to self.first node. Okay, because this access data in the array tree at index first node. So to access data at index first node, then I can write that self.string, okay, then current. So this is the object of the data at this index. Don't forget that current is 0 because first node is 0. But this will not return the data, it only returns the object. To get the data, don't forget that in the class node, we have a function that returns the data, which is get data. So that function needs to be called. Okay, so that would be self.string current dot get data. So this is the function that returns the data. I hope you understand that. Compares it to the data in new node. So we need to return the data in new node. So that is also new node dot get data. Okay, so since we are comparing, let's use less. So compare to take it to the left first. Okay, So I have to write if it is less than, if the data, if the new data, that is the new node, is less than the data accessed. So let's go back to our drawing board. So with this is at index 1, isn't it? So we are trying to check the new data, which is the new node. That is value 9. If it is less than the data at index 0, right? The data returned by this function from index 0, which is 15. So if it is less, that means we have to go to the left. And going to the left means we deal with what? We deal with the left pointer, isn't it? So we need to access the left pointer before we go to the left. So if the left pointer is -1, that means there is no value to the left. If the left pointer is not -1, that means there is a value to the left. Is that understood? So let's go back to the question, but we understand what we have done, right? This value is taken and compared to this value. So the question says that repeatedly follows the pointer until the correct position for new node is found. That is, you continue to follow the pointer. So follow the pointer means that, look at the pointer is -1. That means there is no node to the left. If there was a node, pointer would not be -1. That means you continue to follow the node until you get to -1. Is that understood? So that means that we can write this function because we are repeatedly doing something until the condition is met. So we can write it as y the pointer is not equal to -1. Okay, so that means we need to follow this until the pointer is -1. So first and foremost, we need to first get the pointer. That is the first thing to do. We get the pointer. So we need to get the pointer of what? Of the parent node, because the pointer of the parent node is -1. We need to get that first. Is that understood? That is the first thing, because to check if the pointer is -1, the first thing is to get the pointer. If you don't get the pointer, then you can't check. So that means that current is now equal to self dot string current dot get left. Why am I using get left? Because if the value is left, then we tend towards the left. That is, we will go towards the left. So we deal with the left pointer. So what this does, don't forget that the initial comment was 0, isn't it? Because this value 9 is now less than 15, so we are changing the value for the current now. So the value for the current is now equal to the left pointer of the parent. The parent is the value at the 0 position, right? So this line of code will get the left pointer of the value at the 0th position, then save it in current. Is that understood? So that means this pointer, this value of -1 is now saved as current. So now we have to write our code. Don't forget that repeatedly does something, right? So that means I need a while loop. Maybe y current is not equal to -1, or I write y2. If I write y2, that means I need to break the loop, okay, when current is -1. Okay, then I write if current is equal to -1. What does that mean? That means the position has been found. Because position to insert the left pointer or the position of 9 is at that point where the left pointer is -1. So that means 9 will be at this position. Is this understood? Because it is -1. So if you go back to the question, it says repeatedly follows the pointer until the correct position for new node is found. So the correct position for new node is at that point where the left or right pointer is -1. So if that value is less than the first value, so that means we're dealing with the left pointer. If it is greater than, we're dealing with the right pointer. So at this position where left pointer is -1, that is the position of the new node. I hope you understand that. So once the position is found, now that we found that if current is equal to -1 means the position is now found. Okay. So once the position is found, insert node sets the left or right pointer of its parent node. That means the left or right pointer of the parent. Don't forget the parent is at what? Is at this position 0, right? So the left pointer is now changed. Is that understood? So once the position is found, insert node sets the left or right pointer of its parent node. So it's now changed. Is that understood? It's no longer, it should no longer be what? It should no longer be -1. So now that the position is found, that means 9 is now at position what? Is now at position 1. So the value changes from -1 to 1. Is that understood? So that means that we write here that self dot string, okay, the pointer at that position current, okay, dot set left, okay, -1. You understand what set left does? In this function, set left sets the left, assigns the parameter value to left pointer. Can you see? Assigns parameter value to left pointer. So what is the parameter value? No, not -1. That should be 1, not -1, isn't it? And what is that one? The number of nodes. So that should be self dot number of nodes. Is that understood? Which is now 1. I hope this is understood. So number of nodes is passed as a parameter for set left, which sets that value to the left pointer. So now that line of code has been answered. Is this understood? So that is for left. So what if the value is not -1? What should happen? So after this has been set, of course, the loop should break the loop and get out of it, because this will continue to do it until it is -1. Is that understood? So let's try and check if what we have written is correct, if there's no problem with what we have written. So we need to check that what if current is not equal to -1? So that is to say, let's take for example, in this point there was 9. Then we want to add -3. Yeah, before we add -3, don't forget that after 9 has been added, number node is supposed to increase to 2, because we now have 2 values in the node. If you even go back to the question, it states that increment number node. Once the position is found, insert node sets the left or right pointer of its parent node, then increment. Okay, so now that that value has been added, when left pointer is -1, we get out of the old loop and increase number node. Okay, so that means that self dot number nodes plus equals to 1. So we need to do it after everything is done repeatedly. That should be after while loop. Okay, that is the reason why I need to take it out of this while loop. Now, but still in the else, in this else function. So the question is, what if now that number node is now 2, what if I want to add 3, -3? So we are sure that this code is working correctly, and if there's something we need to add, then we need to add that. Now to check, according to this code, first thing, it checks if number node is 0, but number node is 2. That means this is false, right? Then it goes to else. When it gets to else, self.string, self.number node is equal to, that is, it adds new node to the what? To the position of number node in the array. So what is number position of number node? That is position 2, isn't it? So it has the value -3, isn't it? So it has the new node in that value, in that position. I hope that is understood. Current is equal to self dot first node. Don't forget that this is starting again. So while after it breaks out, it means that is starting again. So that means current is now equals to 0, because self dot first node is 0. Is this understood? So it is 0 because initially the value of self dot first node was not changed, right? It was 0. So now that that is 0, so that means that the value, the new node value, the data value is what? Is gotten and compared with the first value because current is 0, right? So that value is compared with the first value. So what is the value? The value is minus 3 is compared with what? With 15, which is the first value. Okay. Now if we go back to this, minus 3 is the data from the new node, while self dot tree current is 0. Don't forget first node is 0. Dot get data, that will get the data of the first index in the tree. After comparing, don't forget that this is now less than this. That means we need to deal with the left pointer. Is that understood? Then this code, don't forget, will return the left pointer because it returns the left pointer of the zeroed position. Is that understood? So self dot tree 0 dot left dot get left. So this returns the left pointer of the 0 position and save it as what? Current. That means current is now 1 because the left pointer of the 0 position is what? Is 1. Is this understood? Is it equal to minus 1? The answer is no. So now that it is not minus 1, that means it still starts again because it will not break out of the loop. It starts the while loop again. The while loop will do it repeatedly. Okay. Now, when it starts the while loop again, then this is now what? New node dot get data, which is the past value part, which is still the minus 3, is now compared with self dot tree current. Don't forget that current is now 1. Is this understood? Current is now 1. So it's comparing it with the 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 index 1, the value at index 1 in the tree data, and that value is what? Is 9. So that means minus 3 is now compared to 9. I hope this is understood. Since minus 3 is now compared to 9, so this means we need to deal with the left pointer because the value is what? Is less than 9. I hope you understand. So now that it's less than 9, don't forget that at the end of 9, the left pointer is minus 1, the right pointer is also what? Minus 1. So the question now says if current is equal to minus 1, don't forget that it is now minus 1. That means this is true. So self dot tree current. So it is changing the left pointer of what? Data in position 1. So this data in position 1 is 9. So the left pointer is supposed to change. Is that understood? To be set to what? To the number of node, which is now 2. So this minus 1 is supposed to change to 2. Is this understood? But if you look at this code, current is minus 1. So there is no position of minus 1 in the array. There is only position of 0, 1, 2, 3, 4, isn't it? So there is no position of minus 1. So that means there is something wrong with this part of the code. Is that understood? This current should be the current of the previous before current is minus 1. So that means I need to adjust this code to be able to do that, to be able to solve that problem. So in doing that, so I need to come here after the while loop and write that parent is equal to current because I want to change the pointer of the parent node. 9 is now the parent node, right? So I want to change the pointer of the parent node. Okay, then I should get the parent data. I should get the parent data so that when current is 0, let's take analysis. So this should also be parent. So we'll do the analysis now so that you guys can understand that. Now let's start again. 3 is minus 3 is about to be added, right? So let me clean this because minus 3 is not I want to simulate that so that you guys can I want to dry on that so that you can see what that is. Okay, now we want to add minus 3. to this node, right? So the first thing, it checks if number of node is 0. Of course, number of node is not 0, it is 2, right? Since it is true, it is 2, that means this condition is false. Okay, this condition is false, then it moves to the else. Now, self.tree, self.number node, that is in the tree array in position number node, which is position 2, the value tree node is added. Okay, the value what? The value new node is added to that position 2. So that means that minus 3 is now added to position 2. Is this understood? Now that that is added, current is equal to self.first. That means current is equal to 0 because first node is 0. It was not changed from 0. Why true? Then look at this. Well, I said parent is equal to current. That means parent is also what? Parent is also equal to 0. Current is also equal to 0, right? Since parent and current are the same value, we don't have to worry about that. This gets the new node data, which is now minus 3, right? So which is now minus 3, which is the new node data. It compares it with what? With the element in the first element. Don't forget that parent is 0, isn't it? Parent is 0. So it compares it with the first element in the array. The data, first data in the array, which is what? Which is 15. So since it is less, then it goes to get another current. What is now the current? The 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 left pointer of 0th position, right? So even if I write parent, it's still the same thing. So self.tree current.getLeft. So what is current? It's still 0. So it's going to get the left pointer of the 0th element. Is that understood? Which is the left pointer of what? Of 15. So the left pointer of 15 is 1, isn't it? So that means current is not equal to minus 1. So it goes back again to the while loop and start again. Now, parent is equal to current. That means parent is now 1. Both parent and current will have a value of 1 because that is the value returned by this current, isn't it? So parent is now equal to 1. Current is also equal to 1. Okay? Since both are 1, so it comes back here and gets the data, which is still what? Minus 3. Then check if it is less than the value in the first position in what? In the array. The value in the first position is what? Is 9. Is it not less? It is still less, so it deals with the left pointer. So now, what is the left pointer? The left pointer of this element is now what? Is now minus 1, isn't it? So since it is minus 1, that means there is no element to the left. Since there is no element to the left, that means that this is now self.tree 1. Don't forget that parent is now 1. It is only current that has changed to minus 1. Parent still remains 1. Is that understood? So that means that the left pointer of this one, that is of data 1, which is 9, is now set to what? Is now set to number nodes, which is now 2. So this is set from minus 1 to 2. I hope this is understood. It's set from minus 1 to 2. So that means these parents have satisfied the F. So even if you write parents here in the current, it still gives you the same thing. Nothing changes. So having done that, what we have just solved is if the value is less than the parent value. So what we have just done is working with the left hand side. So the next thing is, what if the value tends towards the right? If the value tends towards the right, we will do the same thing as we have done in the left. Okay, we'll do the same thing as we have done in the left if the value tends towards the right. You know, when the value tends towards the left, that is when the search value, when the value we want to input is less than the parent value, we always move to the left. But for the right parameter, we do the same thing. Instead of getting the value from the right, we get the value from the right. Instead of setting the value from the left, we set the value at the right. Okay, so that means we go back to our code, which also says, if I go back to the question, it says, once the position is found, insert node sets the left or right pointer. So we are done with the left. So let's also do that of the right. Okay, so if this is less than this is the left. So this is the condition for the left. So for the right, if it is greater than, so that means I have this as else. Okay. So I do the same thing, but for the to the right. Then I write that current is equal to self dot tree current. Okay. Current dot get right to return the right pointer. Okay. Then we also write that if current is equal to -1, okay, then self dot string, if it is -1, self dot string, then parent dot set right, okay, set right, then self dot number nodes, self dot number nodes. How this is understood? So we're setting the right pointer to number nodes. Okay. Then after that is done, then break out of the while loop. So what we've done in the left hand side, we've also done it in the right hand side. So with this code, we've been able to solve question on question 2b. I has been solved completely. Okay, so the insert code question is written. So let's move on to the next question, 2b. So it states the method output string outputs the left pointer, the data, and the right pointer for each node that has been inserted into the tree. The outputs are in the order they are saved in the array. If there are no nodes in the array, the procedure outputs no nodes. Write the program code for what? For output tree. So let's write the program code for output tree. So that is also in our class function. So I have this as def output tree. It doesn't take any parameters, so I have to write self. Okay. So according to the question, it does not take any parameter. So it outputs the left pointer, data, and right pointer for each node that has been inserted into the tree. And it should output it in the order they are saved in the array. If there are no nodes, it should return no nodes. So let's write this first. If there are no nodes. So don't forget that if there are no nodes, that means number nodes is equal to 0, isn't it? So I have to write that if self dot number nodes is equal to 0, okay, then I write print no nodes. So that is done. That means if there are no nodes, it prints no nodes. If there are no nodes in the array, the procedure outputs no node. So if there are nodes, then it outputs left, data, and right pointer. If there are nodes, if it is not empty. So else. So we want to output all the elements in the array and the pointers. That is what we want to do. So we want to output all the elements in the array. So it says the outputs are in the order they are saved in the array. So and don't forget that the data is the element in the array and their respective pointers. Okay. So that means we must be able to output in the number we have to loop in the required number of nodes, isn't it? If we have 5 nodes, that means we loop 5 times. If we have 20 nodes, we loop 20 times. So we now write that for x in range of what? Self dot number node. That is, go from 0 to what? To number nodes, to the amount, to the quantity of nodes. Okay. Then let's output all the objects in the array. So let's call it, let's say node is equal to self dot tree I. What would this do? This will actually, okay, not I, X. This will save all the objects in the tree. Don't forget that the tree has objects, object value of nodes, not value, not just an integer value. It has object values. Okay, so this node will now take all the object values. Okay, now that has been done, so we have to print. So print format. Okay, so node dot get left. Don't forget, get left is what is used to get the left pointer, isn't it? So node dot get left to get the left pointer. Okay, then also, yeah, node dot get data. Then this function will return the data, okay, in that node tree, and also node dot get right. So this returns the right pointer of each of the elements in the array. So this returns the left data and the right pointer of each of the elements in the array. So that is the function output tree. Okay. So now that that is done, so this question is fully answered. That is just 4 marks. And also the previous question we answered was 6 marks. Can you see it's a lot, but it's just 6 marks. Okay, good. Now, the next, for question 2C, it states, the main program declares an instance of tree class with the identifier the tree. So this is the object handler for this class. When you call this class as an object, this will be the object handler. Okay, so identifier is just like a variable, is another word for variable. So this declares an instance of the tree with the identifier tree class. Write the code for main program. So that means that we have to type it outside of the class. We are out of the class. Okay, so the class, so that means the, is it the class? Yes, the tree is equal to an instance of the tree class. So that is tree class. Okay, so this is not an object. So the tree is now an object handler of tree class. And don't forget, tree class does not take any parameter, isn't it? It doesn't take any parameter. Now, the question now states, write the program code for the main program. So that is written, it's just 1 mark, we've written that. So the main program inserts the following integers into binary tree in the order given. So that means we need to use the insert function. The main program then calls the method output tree. Write the program code to amend the main program. So don't forget that the class, the tree class object will be used to input this data, because it is the tree class object that that works with the binary tree, and it even has the function insert. Okay, if you can still remember. So let's input that one by one in this order into the binary tree. So if you try to input these values into the binary tree, don't forget it will input this into an array. And don't forget that each array, if you want to insert, you need to use the insert function, right? The insert function. So it takes a new node as a parameter, and this new node must be of data type node. Don't forget, from the question, must be of data type node. The method insert node takes a node object, new node, as a parameter. So new node is a node object. So anything we are inserting into the binary tree must be a node object. Is that understood? So before we call the function insert, because now that we know we are inserting 10, we are supposed to write that the tree dot insert node then 10, which is wrong. So we can't insert 10. We need to insert the node of 10. So that means that we have another object handler. Let's say n1 is equal to node 10. Is this understood? So we insert n1, which is also the node of 10. I hope this is understood. Because the insert function requires a node object as a parameter, not just an integer value. Okay, so that is the first one. Then the second one is 1151. So let me just copy this over and over again. For 11, for 5, for 1. I also have for 2715. 2715. So let me change this to N2, N3, N4, N5, N6, and N7. So this is 10, 10, 11, 5, 1, 27, 15. So this is 11. So 10, 11, 5, 1, 27, 15. And don't forget to change the inputs, okay? The parameters as well to N2, N3, N4, N5, N6, and N7. So I hope this is well understood. Okay, good. The main program then calls the output tree, the method output tree. So after all this has been inserted, they will call the method output tree, right? And don't forget the output tree is also in what? In the class tree class. So that means, and the object handler for tree class is the tree. So you also call the tree dot output tree. It requires no parameter. Okay. Okay. Now test your program. Take a screenshot. So let's test this program. Let's run it. So can you see that? So this is an illustration of what I have explained earlier. Illustration of what I have explained earlier. So this is the end of the question. So let's check if everything we've done is correct. Okay. Let's try to draw the graphical representation and put the pointers to confirm if what we have gotten as our answer or from the terminal is correct. So let's check. The input values are 10, 11, 5. Okay, the input values are 10, 11, 5. Okay, let me close this. Okay, so let me come back here to open a new page. So the input values are 10, 11, 5. Okay, and 10, 11, 5, 127, 15. 127, 15. So if you would draw the binary tree diagram, so the parent will be 10, 11 turns to the right, then 5 turns towards the left because it's less, right? I hope everyone understand what I'm doing. So this is 1, 20 turns towards the right, 20, then 7, 5, 7, then the next is 15. 15 should be to the left of 20. Yes, 15 should be the left of 20. Okay, good. So if this is an array, of numbers, okay, then this should be in position 0, position 1, 2, 3, 4, 5, 6, isn't it? So let me use another color of pen to write that. So that means 10 is the parent. So to the right of 10 is 5, which is position 2, right? Sorry, to the left of 10 is 5, which is position 2. To the right of 10 is 11, which is position 1. Okay. Now, for 5, to the left of 5 is 1, which is position 3. To the right of 5 is 7, which is position 5. Now for 20, to the left of 20 is 4. So is to the right of 11 is 20, which is position 4. To the left of 20 is 15, which is position 6. Okay. Now, for the left of 1 is null. For the right of 1 is null. Can you still remember? Left of 7 is null. Right of 7 is null. Left of 6 is null. Right of 6 is null, right? The right of 20 is null. The left of 11 is null, isn't it? So this is complete. So that means if I have my diagram according to my previous explanation, then this should be 10, 11, 5, 1, 20, 7, 15, right? To the left, so to the left of 10 is 2, to the right is 1. To the left of 11 is minus 1, to the right is 4. So now I'm writing the left pointer and right pointer. Then this is the data, okay? To the left of 5 is minus 1, to the right of 5 is minus 1. To the left of 1 is minus 1, to the right of 1 is minus 1. To the left of 20 is 6, to the right of 20 is minus 1. To the left of 7 is minus 1. To the right of 7 is minus 1. To the left of 15 is minus 1. Right of 15 is minus 1. So this should be the expected data that should be printed out. So I hope this is understood. So let's go back to the code that was run. So 10 to the left 2. Can you see? 10 to the left 2, to the right 1. You can see 2, 1, then minus 1, 11, 4, minus 1, 5, 5, minus 1, 5, minus 5. That means there's a mistake there. Let's check that out. So before I check it out, let me check others so that I can know the number of mistakes I have. Okay. So this is minus 1, 5, minus 1. So 5. Oh, there's a mistake here. 5 is 3 and 5. Can you see? To the left of 5 is 3, to the right of 5 is 5. So that means there is a mistake. They have seen my mistake. It was me who wrote something wrong here. So let me take an eraser to clean this. So according to this diagram, to the left of 5 is 3, to the right of 5 is 5, right? So that is 3, 5. Okay. So let's take a look at it. So that's I have 355, which is now correct. 355. Then minus 1, 1 minus 1. Then 620 minus 1. Minus 1, 7 minus 1. Minus 1, 15 minus 1, which is absolutely correct. So that means this data representation is also this graphical representation. Okay, it's also this graphical what representation is what you have just printed on your console. Okay, so I hope this is well understood. Don't forget to like this video and subscribe. So I'm working on solving more questions on binary tree and class, and I hope that should be uploaded today or tomorrow. Thank you so much for your attention. If you have any question, please write them in the comments. Don't forget to like and subscribe to this channel. Thank you.